Hey everyone, Eth Klein here, and today we're going to be going over a Python library called Pandas, which is a great library for all sorts of things, but especially data analysis. And so today I wanted to do a quick walkthrough of it just because I've used it in my other videos, but it's a little bit of a new concept and a specific library in Python, so it's really nice to get some good background knowledge in it. So today I'm going to be going over that. And before we hop in, I'm going to recommend that everyone download this program, which runs on your local host in your browser, where you can use Python for all sorts of things within this notebook environment. And so you're going to want to go to jupyter.org and download the notebook. I'm using the classic Jupyter notebook, and you can install that and then run it from your command prompt with the instructions they give you. And it gives you this great environment where you can do some great analysis with even like markup text and code, and then display the results. So you can see your graphical creations if you're creating a GUI or some sort of matplotlib graph right in your browser. So it's great to be able to do that and see your analysis like immediately. So for Pandas, the main thing that you use is a data frame. And so what I would like to do in this tutorial is use a Kaggle dataset, and we're going to use something that's relevant currently, which is the COVID-19 world vaccine progress. So once you create an account, you can download the CSV file that goes along with this, and we'll be going into that shortly, and we could use that CSV file, import it into Python, and use Pandas in order to extract some insights from the data, which is always really interesting. So let's go over Pandas a little bit. So Pandas is a Python library used for working with data sets. You can use it to analyze, clean, explore, and manipulate data. And it was created in 2008 while Python was created in the early 90s. So it's a relatively new library. So you should use Pandas for analyzing some big data and then make conclusions based on some statistical theories on the data. And it can clean messy data sets very well and make them quite easily readable, and makes the data more relevant, which is really important for any sort of analysis you're doing. So you can look at things as like the correlation between two or more columns, the average value of a set of data, max or min value, and it does really well with working with null or incomplete data. And that's always extremely important when working with more raw data sets. So to install it, we're going to, I'll pull up a command prompt. So from here, we can do a install pip install pandas, and that should get you going. I don't have pip on here, but if you download pip, which we can go here, okay, so once you've pip installed Pandas, which should be easy to do because pip will be automatically installed with the latest versions of Python, I'm going to run through a quick little sample of using it with a made-up data set, and then we can hop in later once we get some groundwork to the main CSV data set. So if we import Pandas as PD, so basically what this does is it imports the package, and it does it as PD. So when we want to call Pandas functions, instead of writing pandas dot the method, we can do PD dot the method, which is really common practice when doing programming with Pandas. It's very common to do import Pandas as PD to use that PD abbreviation. So if we run that, we'll know that it's been successfully installed. So now we have Pandas. So let's create a data set, create like a little dictionary, names. We can do Ethan, Talia, We could do height. We can do, instead of, so those are names are in a string format, we can do 5, 7, 10. So now we have a data set that has 2 columns, names and height. So the names are strings and the height are integer values. So we can do df, which is a common abbreviation for data frame, which is the main pandas data structure. So pd, which is what we imported up here, pandas, dot data frame, and put the my dataset inside. So what this is doing is it's transforming this my dataset variable with these 2 dictionary key value pairs, the key being the names and the value being this list of strings, and then this, the key being the height and the value being this list of integers. And they're both the same size, so they're both size 3, so it'll be aligning each name with the specific height. So we do that, and we're just going to run a view our data frame output. So here we can see this data set is transformed into a data frame, and we have the names column with the 3 names we included, Ethan, Talia, and Mike, and the height column with 3 integers, 5, 7, and 10. And so what we have here now is our first data frame. So this is really powerful. So now we have everything inside an actual data frame, which makes it really interesting to work with. And before we dive too much into data frame, I also want to go over the Pandas series real quick, which is like a column in a table. So it's a one-dimensional array holding data of any type. So see, this is a 2-dimensional data structure. So if we have, let's say, we'll just work with the height, 5, 7, 10. So this is 1-dimensional of size 3 integers. And then we do my series is equal to PD, which is pandas. So we're using the Pandas series. Now there are other series in Python. So the pd.series is specifying that this is a Pandas series. And we use the height. Oops. And let's go ahead and print that out. And so now we can see that it has the values here, but you can also see it has a little 0, 1, 2. And this is just denoting the elements within the number elements within the series. So it starts at 0 because it's a common programming practice, especially in Python. So the first element of its array is the 0th element. Then it goes up from there. So if a array size is 10, the last element would be the 9th element because the first element is the 0th element. Then underneath it says dtype. So the data type for these are integers, 64-bit integers. And that means that every element in the series is an integer. So if we look into this series a little bit more, we see the 0, 1, 2, and those are really called labels. So if we were to extract the labels, let's say we want to view this 7, right? And it's paired up to the label 1. So we can do my series 1. You can think, oh, 1, it's the first element, but since it's starting at 0, it's actually the second element in the series. So we get this print down here. Let me just clean this up so we can only see 1 at once. So I'll comment that out. So it's 7, right, instead of 5, because that's the 0th element. The second element is the first. So that's how you access a specific value within a series. And this can also be applicable to data frames, but in a slightly more, not advanced, but a slightly different manner since it's a multi-dimensional data structure rather than a single dimension like a series. So that's really a nice introduction to series. But in addition to that, you can do a key value object similar to this key value object, except it's just 1. So you could have a key, which can be, we can make this, okay, can make names height equals this, so that the braces are a denotation of a key value kind of dictionary. And then we'll, instead of doing pd.dataframe, we'll convert it into a series. So we can do, let's do Ethan maps to 5, comma, Talia maps to 7, and Mike maps to 10. So now we have these 3 individual entries into the series, into the dictionary, and they each map to specific values. So the first element in the mapping is the key, and then the next is the value. So key value, then key value. Okay, so now we have that. And if we do my key val, just the variable name, is pd.series of names height. If we go ahead and run that, let's print out the results. So now we have a series that looks familiar to the data frame we have here. So you can see that it has the same structure, although there's no reference to the column names of names and height. It's simply a pairing, a unidimensional pairing of a name to a height. So this is definitely an important thing to have. And with less structured data, it's very good to have a series, because the time complexity of adding and withdrawing and searching through the series is very quick as compared to a large data frame. So it's just one dimension, the max is log n, which is the time it takes to iterate once through the entire series. And you can see here it even has the D type of int64. So you may be wondering, well, why is that? And it's because it's looking at the value pair, which is in fact an integer. So to jump from these series back to data frames. So data sets in Pandas are usually multi-dimensional tables, and those are called data frames, as opposed to the series, which is a single dimension. So the series is similar to a column, and the data frame is the whole table. Is a good way to think about it. So now let's jump back in. We've looked at some, this data frame, my data set. We can go back into it. We've printed it out. And let's say you want to locate a specific row in the above data frame. So you can do print, just to look at it, df, since we've named the data frame df here, dot lock location. It's an attribute of a data frame. Let's do the 0th element. So now we ignore just to take a look at the single output. So we have the data frame, the names is equivalent to Ethan, the height is 5, and it's an object. So we're looking at an object. Since it's not just one value that's returned, it's the whole object consisting of a name and a height. And if we want to look at, and also just to note, this is a series that's being returned, similar to this, Ethan 5.7, it's Ethan 5. If we want to look at more specific value, so now, lock 0, 1, you are returning row 0 and row 1, so Ethan and Celia, and their heights. So this lock, because it's a multi-dimensional output, rather than just Ethan 5, a key value, a series, it's Ethan 5, Talia 7, then it's returning a data frame. So you can really move very easily between Pandas Series and Panda data frames, depending on the data you want to extract. So you have a data set, you can extract a subset of that, which could be another data set, or if it's just one dimension, it'll be Pandas Series. And so you could also locate by a specific value or key. So we're going to be look up through Talia. So why did this give an error? So it's looking up by rows, right? We're not looking up by the, we're not in the location, we're not indexing by Talia. That's an important thing. So you have to look at it by the, if you want to look at 1, that'll return Talia, because it's really the first or second entry, but first index into the data frame. If you want to look at it, if you want to look for a specific name in it, that'll come later, but it's not as easy as looking through the rows. So you have to remember that df.lock only looks at the rows. It doesn't look into the values themselves. It just says, okay, df.lock1, I'm going 0, 1, and then just extracting all the information there. So this is a series. So it returns a series since it's just one dimension, a key value pair, and it's that simple. So we have some decent knowledge on that, and now we're going to look into using that CSV file we looked at before. So let's look. I have this that I downloaded from the World Vaccinations Progress, and you want to make sure you put it in the same folder that your Jupyter Notebook's in, because that way you could access it very easily. So it's in Documents, Python scripts. So once you have it in a folder that you could access, you can copy the link. And then we're going to import it into Pandas, into this notebook, in order to read the actual data. df equals pd, so pandas, the imported pandas we have, .csv. And then we're going to include the .read_CSV. Okay, so now I have the country vaccination CSV in the same folder where my current notebook is, Introduction to Python Pandas, right here. So in the same folder. So now I can just do a df.read_CSV of the CSV file name. And let's go ahead and run this cell. Okay, so now we're looking at the Excel file, which I could pull up here. So this Excel file and all the columns and rows are now imported into this, into Pandas. And so that's a really easy way to get this data straight from a CSV into its own data structure in Python. And now it can use Pandas and Python in general for really analyzing data in any way we want to. And this comes with a lot of benefits, and also it's very highly optimized and can quickly issue commands on an extremely large data set that you otherwise would not be able to issue commands very easily on. So this data set, yeah, it's 1,400 rows, so a solid size, and it's containing the countries and then some information about the vaccinations that are occurring. And it's listed by date, so I have that here. And then it has total vaccinations, and you can see everything that it has in this Kaggle explanation with the country code, the date, total vaccinations, and then it has a source name and source website. So now we have all that information in this data frame. And right now, we type in print data frame, and it's a little bit messy because it shows like the first few entries and the last few entries because it's a big data set, so it can't display everything all at once, or you wouldn't ideally want to, because it'll clog up some of the space you have for the actual code. So if you want to look at, let's say, the first 5 entries, we could do df.head5. Let me clean this up so it doesn't look quite as messy. All right, so here we go. It has the top 5 0 because it starts with the 0th element through 4. So n-1 is the last element. And it has the country code, the date, total vaccinations, people vaccinated, and the source website. And so it has everything here. And since there are a lot of columns, they're up to O, so it's going to be a little bit annoying to display visually just because of the screen size. But you can easily just look at one at a time, and that'll be easy to see kind of what's going on in the data set. And so you could easily look at that, the first 5 and the last 5 with tail. So then it's Wales versus Argentina, alphabetical order. Then it has some links to the source where the data is coming from. So it really gives you a lot of information. And also, if you don't really know too much about your data set, you can do df.info, which is a command that will basically tell you a great synopsis of everything that's in the data. So range 1,397 entries from 0 to 1396, total of 15 columns, and it lists all the columns in a great, easy to read format. The non-null count, so the count of values in each column that's not null or empty, an empty cell in Excel. The type that is within that cell, so some are floats, and then some are objects. Objects and the floats are the actual values that we're looking at. So data object, country, and then it has some floats, which are these. Even though they're represented here as integers, floats just means that it can go out to a few decimal places. It's not purely an integer data type. Has memory usage, the total counts of the objects, so it really gives you a great synopsis of really everything that's going on in the data. And that's always important when you have a brand new data set that you don't really know much about. So some examples of clean the data, even though this data set is quite clean, even though you could see that people vaccinated, this value is not equal to this value. So you know that there has to be some, or it's less than that value, so there has to be some empty values. And that's really apparent in these when there's 200 out of the 13, almost 1,400 values they have. And you can see by quickly looking at the data that there's a lot of empty values. So, you're not always satisfied with that. So this bad data could be in the form of empty cells, which we have a lot of, data in the wrong format, which we don't really have a lot of because integers being represented as floats is not a issue we need to worry about since they're both different forms of numbers. Wrong data, which we're not sure of really because we just picked this data up from Kaggle and we're assuming, right, for this project that this data is collected correctly, but you can never be certain, and that's why you want to really have a lot of pre-data analysis in order to ensure the data you have in the first place is correct, and make sure there's no duplicate values, which there shouldn't be in this data set. So really, a good thing to start out with that can give you a lot of insights is creating a new data frame with this df, which we read in from the CSV. Do drop NA. So this is creating the rows that contain empty cells. Then we're going to print new df.toString just to read it a little bit more easily. So it has all the headers on top and then some information. You can see a lot of rows got deleted. It's jumping around 95, 25. So there's a lot of missing values in this data set. And we don't necessarily want to delete a whole row just because there's not data in every cell. That doesn't necessarily contribute to the whole cell or the whole row being invalid for our use of data analysis. Sometimes we just want, some values and from the row, and it doesn't matter if everything is there or not. And there's ways to, instead of just dropping the missing cells, we can do fill NA, and so with that we can fill, let's say, all the values that are empty with the string empty. We can do it in place, which basically means we're manipulating the the data frame itself. Right, so now we can see, once I print out the data frame, that this row, let's see, it's between 700 and 32,000. It's an empty cell, and now in Pandas it has the text, the string, empty. So now we can really get an idea of what's empty and what isn't, and it'll be a lot easier to read and visualize. And we can search for keywords like empty in order to see which cells are missing. But really this is not too necessary for right now because this data set is relatively safe to use. We can look at some other things though, like let's look mean. We can look at the total vaccinations. So see how I'm indexing into the data frame using df brackets and then single quotes for the column name total vaccinations, which is this column right here. And I'm just going to do a dot mean. So we're just going to get the average. This is how simple it is to get the average of the entire row. So now we have the value. And when you're doing dot mean, it will not include the empty values as zeros because that will skew this number quite a bit. And that's important when we're working with some values that are empty. But if you do what we did prior and do fill NA with 0, then you'll get a much more, it'll be skewed down quite a bit to account for all the zeros in the data. Now we can look at the median quite easily. The median, let's actually compare those two values. So now we can look at a comparison between the median and mean. So we can see that the median is about 63,000 and the mean is 590,000. So there are some real outliers on the upper end of the tail that are driving this distribution way up. So you can see just from this analysis right now that we have some big outliers that we're going to want to look into and see what the issue is, or why it exists. And a quick max, just because it's interesting. Now that we have the median and the mean, look at the max. So the max is 20 million, 20.5 million. So that's a fairly large value, especially when we're looking at a mean of 63,000. Look at the min. This will really give us some good insights onto what so the min is 0. But 20 million as opposed to 63,000 is quite a difference. So let's look into some correlations, because Pandas is really good for looking into different relationships between variables, and specifically the core method, which is this df.core, standing for correlation. And so it calculates the relationship between each different column in the data set. So using this country vaccinations as an example, we can print the df core and look at some of the differences between the columns. So this takes column by column and it compares it to different columns. So you have total vaccinations. We're looking at a 1 correlation, which is because, well, they're the same column. So the results of core method is a table, which we see here, with a lot of numbers that represent how well the relationship is between those two columns. The number will vary between -1 and 1. And 1 means there's a 1-to-1 or a perfect correlation. And for this data set, that'll be when the columns are the same because the numbers are exactly the same. So 0.9 is a relatively strong relationship, and -0.9 would be just as strong as 0.9 except in the opposite direction, so they're correlated in a negative fashion. Good correlation really depends on your data set and what you're looking at. But I mean, if you're looking at over like a 0.6 or a -0.6, you can call that an interesting thing to look into, at the very least. So we're looking at some pretty strong correlations here. Some are not as strong, but overall, things that aren't related, as in like people vaccinated per 100, people fully vaccinated, daily vaccinations. So those are in the same method of gathering data. They're about vaccinations. And daily vaccinations raw versus just daily vaccinations is going to be quite similar because the data in and of itself is collected from the same source. So if we want to look at plotting is always a great tool with Pandas, and especially matplotlib in these Jupyter notebooks. So if we import matplotlib.pyplot as plt, so this is a common abbreviation for the matplotlib pyplot. So now we have the CSV read in, and it's under the variable df, so df.plot. And then we're going to show that data frame, and Jupyter Notebooks will show us it right inside. Oops. It did it regardless, but we're going to call the df.plot, which plots it, and then the plot plt.show is using the pyplot library to show it. So really, we didn't really do much, and it creates a pretty interesting looking graph that you can, this is just a graph that they generated with each of these different colors representing a different column, then some different values, which is just an interesting way to immediately look at something. And you would really never just plot it immediately. Maybe we can look at a different kind of plot. So maybe we could check out a scatter plot. Do kind equals scatter. We could have the x-axis be total vaccinations, maybe, and the y-axis be total people fully vaccinated. So now we've really emphasized to matplotlib what exactly we want to look at, where we have the kind, which is a scatter plot, and then the x-axis, which is total vaccinations, and the y-axis, which is people fully vaccinated. If we run this, you can see some clustering at the lower end, the 1 people fully vaccinated, the 0.5 total vaccinations. And we can see this little trend line, which is quite linear in nature. We can see a lot of different clustering in certain areas, especially around 0.5 and then 0, 0. So really you can take these insights and look into a lot of different things. We could even try to flip this around. And look at something kind of like a histogram, which is always a good plot to look at when there's clustering involved. And so if instead of kind we use scatter, we could even use df people fully vaccinated. So we're only plotting this people fully vaccinated column within the data frame. And if we do dot plot and set the kind equal to hist, oops, in quotes, hist. So now we have this histogram. So you can see it's very centered toward the left, and there's a few strong outliers that are really they're not that present, but they definitely skew the mean. Like we've seen up here when we were looking at the mean median mode, there was 20.5 million versus an average of 560,000. So there's some numbers that are really pulling on that, and it's 1 times 10 to the 6. So these are quite big numbers, even though it just says 3.0. It's 30 million. So it's really interesting to look at graphs like these. And I hope this provided like a good insight into data frames. Just so in my next few videos, it's more easy to kind of dive into the meat and potatoes of data analysis. And knowing these data frames is really important because it'll really help you be able to import data from different sources, Excel, even JSON files, and put it into Python and immediately begin to just dive in and looking at simple correlations and seeing like what's up with the data and just getting a great overview of it. So I really hope you guys enjoyed, and please remember to like and subscribe, and I'll look forward to seeing you guys in my next video.